Hello, everybody. We're rather tight on the schedule, so I'm going to start off at the hour, or I'm going to lose some of my end here. My name is Joakim Lehn, and I'm one of the employees here in Oslo. And I'm going to have a presentation about the project we had for one of our biggest customers here in Oslo last summer, which is actually Oslo City or Oslo County. So my presentation is going to be about why we introduced machine learning from our customer, how we did it, and some of the results. So why did we introduce machine learning, except that it's really awesome to do machine learning? It all started when we knew some students were coming to have a summer internship with us. And we wanted to give them a really cool project, a great, interesting summer, so when they go back to school, they can talk about their friends and tell them how awesome Knowit is to work. And so we, at the project, we sat down together and we did a little buzzword bingo, trying to create all of the buzzwords we knew and make up different projects using these buzzwords. And we also had in mind this graph that most of you maybe have seen before from InfoQ, about the technology status around the world. And we really wanted to have a project regarding one of the technologies in the early stage, like the innovator stage, or at least early adapters stage, like machine learning was at the time. So from this buzzword bingo, we came up with almost 20 different projects. And 2 of these were regarding machine learning. None of them were regarding rockets, so that's a misleading picture, but it was still some really awesome projects we came up with. But when we were trying to choose which one to go for, we remember that Jan Henrik, the guy standing here earlier, is the CTO in Knowit ObjectNet here in Oslo. He had a goal for 2017, and that is to introduce machine learning into all our projects by the end of 2017. So with this in mind, we ended up choosing a project which we named Automatic Prediction of Complaints regarding parking tickets given here in Oslo. And we're going to do that by using machine learning, and we're going to train the model with the previous complaints sent in the previous years. So we did that partially because of the goal we had for 2017, but also because we thought this is going to be an exciting project for the students. It's going to be a really cool project, which was half the idea. And we also thought it was more or less realistic that we could do this in 2 months, because that's all the time we had. And we were hoping that this could be a door opener into for our customer to get more machine learning projects for them, because this is a huge customer with a lot of potential for machine learning and other AIs, specters. So what did we do? Well, first of all, we had to convince our customer, because we couldn't just do this without their approval. It's their data, and it's not that sensitive, but it's sensitive enough that not everybody has access to this. So we had a presentation about our idea for the project leader, and we agreed to do this project free of charge as a proof of concept, since they didn't want to use money on something that might not work at all. And we promised that we would share our experience with the customer. So that's a really great way for us to show our customer how much potential machine learning has to do with doing it free of charge. And in return, we would get access to all the data, which is all we really needed from them to do this project. Since we're from different countries, and it's important that we're on the same page, so this is the basic idea. Sometimes when you park in Norway, if you're unlucky and you park illegally, you're going to get a ticket. And if you're like me, you're going to complain about the ticket because it's wrong every time. And the idea was just to take one of these complaints and automatically try to predict the result of the complaint. Would it be rejected? Would it be accepted? We wouldn't try to give a statement of why, but just the end result. And for this customer, we have a lot of different smart forms, forms that adjust dynamically based on the user input. So we could have chosen a lot of different types of forms. But we chose this one in particular because it's the most used form in Oslo. People in Oslo love to complain, especially about parking tickets. And by nature, we knew that parking tickets have some really easy cases. Let's say you park on a sidewalk and you leave your car there for 4 hours and you come back with a parking ticket. You don't need to complain. You know it's going to be a ticket. You can't get away with that. And we also had a lot of historical data, which is partially true, because this had been running in production for 5 or 6 years, and it's about 10,000 complaints every year, so that's a lot of data. What we realized after a couple of weeks, though, is that they introduced some new rules at the start of the year. So all the historical data was slightly corrupted. So in June, when we started this project, we had around 3,000 training examples, which is some amount, but we were hoping for something more. But as I said, we expected around 10,000 complaints a year. So our training set would grow throughout the summer, and especially at the time after the summer. So these were the students that were coming, Marianne and Christopher, and they had no previous experience at all with machine learning. Which makes this even more interesting project because you only have 2 months to do this. So the first thing you had to do was to learn basic machine learning. And the idea was to just start basic and you try out and see what happens. We also developed some sort of a strategy because the goal was to guess the result the caseworker would give the case, accepted or rejected. And we chose pretty quickly to use some key parts of the complaint. That was mainly the violation code, which is a code saying which law you violated. So there's one code for you parked legally, but you didn't pay the parking meter. And there's one code for you parked on the sidewalk. There's one code for you parked too close to an intersection. There's a lot of different codes. So that's a really useful fact when you're complaining. There's also a complaint code. That means the reasoning why you complain, why you disagree. It could, for instance, be my car was stolen, or my son's a narcotic, or a lot of different codes. And you're also going to use the complaint text. You're going to try to analyze what the complaint was really about to see if you can extract some of the data there to make a fair judgment if the ticket was legal or not. We also wanted to use pictures. But the guys giving the parking ticket, they take a lot of weird pictures, different angles, different every time. They're not so good at it. It's easy for a human to see a picture and more or less understand what's going on, but with the amount of training data we had, we couldn't do it with the pictures, unfortunately. And we also wanted to put each case in 3 categories instead of 2. 2 of them is obvious, the accepted and rejected category. But we also wanted a 3rd case, which was unsure. Because as I said earlier, by nature, some of the complaints are really difficult. Even for the caseworkers, the humans can use hours on some of the complaints. And we were trying to use this to our advantage, to say that this is a difficult case, we're not going to be sure about it, and instead of trying to guess the result from it. We also set a goal at the start of the summer. We were hoping to be able to process, and by process I mean put them in one of the 2 accepted or rejected categories, to about 60%, and hoping to get at least 80% precision. That means that we correct at least 80% of the time. Of course, this is not good enough if we wanted to go in production, but it was a good start for a 2-month project. Some of the technology choices we made, most of the components we have for this customer is written in Scala, so we went with that as well, and we used a framework called Sparks. And as an early warning, if you're going to use Spark, don't use version 1 something, because that has some insane memory leaks, which we discovered. So use version 2 and up, then it's really good and stable framework. So Apache Spark is a framework for distributed computing. It's commonly used in big data. It's written in Scala, which is the main reason we chose to use this particular framework. It's got a lot of support and documentation, both for Scala and other languages. And it's got a lot of libraries like MLlib, which is the one we used for machine learning. So the idea is we're going to take predicted data, which is complaints that's been processed by a caseworker in the past. We're going to wash the data, meaning we're going to remove all the words that don't have any meaning by themselves, like but, or there's a lot of stop words that don't give any meaning. And we're going to remove those, and we're going to convert the words into vectors, giving them a numerical value. By those vectors, we're going to train a model, and that's going to give us a complete trained model. And the same way, we're going to take unpredicted tickets that's just been fined, and we're going to wash the data, convert the data to vectors, and put it into the model and see what comes out. Is it accepted or rejected? Not sure. So here are some of the results. We tried a lot of different algorithms. I mentioned only 4 of them here. Some of them were decently good. Like naive Bayes, I was surprised I did manage to do this well, because it's a really simple algorithm. Decision tree has a great score, but it rejected almost everything. It never accepted anything, so that was not really a nice one. If you put that in production, we will be really unpopular. But the best one was support vector machine. And we think that's the reason why is because that's in support vector machine, you can put in thresholds for the different values. So you can say if it's above this threshold, we're pretty sure it's accepted. And if it's below this threshold, it's rejected. But in the area between, you can say we're not sure, it's a difficult case. It has that mechanism by itself. We also tried to combine several different algorithms, and if they agreed, that was the result. But we didn't manage to get equally good result with that strategy as just using support vector machine. But I still like the idea of combining several algorithms to see if they agree. So still, after the summer, it collects data and trains and predicts once every week. And the idea is that it's going to be better for each week. And the results is shown at the dashboard that we created, which is located both at the Knowit headquarters here in Oslo, as well as at the customers. And the precision ended up at the end of the summer at around 83%. And at the moment, it's still bouncing every week between 80 and 90. So some weeks are good, some weeks are less good. And we were hoping it's going to improve more with time, but it hasn't. I think it needs a little bit more love. Nobody has touched the algorithm since August, so if we want it to improve more, we need to spend more time with it. Maybe next summer, who knows? And we learned some things during this project. I can't stress enough how important it is with a large training set. We tried doing the same thing with 1,500 complaints, and the results were horrible. But with 2,500, started to do okay. With 3,000, better. 5,000, even better. But if you really want great results, you need even bigger data sets than that to get enough data to predict. Also, natural language makes it really difficult. We have 2 official languages here in Norway, one great, one bad. And also people write in English, some write in dialect. It's really a mess. People do a lot of weird shit. And it's difficult for us to use any more of the characteristics because we have a lot more data. We could, for instance, include the graphical area where we got ticket or the mark of the car. But it would be really bad if like all the BMWs were fined and all of the Mazdas got accepted or something. So that's also something ethical in the training that you need to be careful about. You might create an algorithm that's discriminating. And the last thing that's the main problem is that we can't get a reason for the classification given by the machine learning algorithm. It's going to say, yeah, I think this is accepted, but we don't know why. So that's reduced the possibilities for the application. But the customer, he was pretty excited. We performed 2 separate presentations for the customers, and we had some ideas, for instance, to incorporate this as a supporting tool for the caseworkers, where they could get an indication on the result. For instance, gonna say, yeah, we think it's an accepted one, but we're not completely sure, or we're definitely sure this is gonna be accepted. That could ease the daily work for the caseworkers and helping them reduce the time on the easy cases and getting more time on the more difficult cases. And they got really excited. We haven't done anything more with this project, but they're gonna have a new proof of concept during the spring on some other applications for machine learning or AI. So I think it was a great door opener for our customer to let them see the opportunities that exist out there. And also we managed to get more enthusiasm inside the company as well, where we're trying to optimize the city bike transportation here in Oslo, because with city bikes, where you get them is usually full or empty. So we're gonna see if you can use machine learning to optimize the placement of them. So the student definitely